So when I plug everything in, I've still got 2 for y, but my m is going to be negative 1/3. Same x. And then you just do the same thing. So I've got 2 equals negative 1/3 times negative 1 is positive 1/3. Alright, you're going to have to do a little bit of fractions here. This goes away. 2 minus 1/3. Anytime you guys subtract fractions, you're going to have to get a common denominator. This is like 2 over 1, so I'm going to multiply top and bottom by 3. I've got 6 over 3 minus 1 over 3. Oops. 6 minus 1 is 5. Okay, so b is 5 over 3. Once you have your m and your b, you're good. So y equals m x plus b. So here's A, parallel, and here's B, perpendicular. My original line was y equals 3x minus 4. So my m is 3, my b is negative 4. Here's my y-intercept. I'm going to go up 3 over 1. There's my line. My parallel line was y equals 3x plus 5. Okay, and if you recall, this needs to be through the point negative 1, 2. Needs to go through this point. Okay, so here my m is 3, my b is 5. 1, 2, 3, 4, 5. I'm going to go up 3 over 1. Close enough. It's a little bit sloppy, but you can kind of see that it's parallel and it goes through this point. The perpendicular line y equals negative 1/3 x plus 5 over 3. In this case, our m is negative 1/3 and our b is 5 over 3. So 5 over 3 is like 1 2/3 if you write that as a mixed number. So it's almost 2. So 1 2/3, it's like right about here. Oops. Okay. And my slope is negative, so I'm going to go down 1 over 3. Kind of, sort of. If you do it right, you should get a perpendicular line. Now mine does not look exact because obviously I'm drawing it freehand, but if you were to do this on graph paper and use a ruler, it should be pretty exact. Alright, why don't you guys go ahead and try this one. Pause the video here. Alright, these are the 2 equations you guys should have gotten. I'm going to graph them down here. Alright, the original equation, what was it? Negative x plus 2. So in this case, my m is negative 1, my b is 2. So start here, go down 1 over 1. There's my original line. Alright. The parallel line y equals negative x And remember, this needs to go through the point 0, 0. So, in this case, my m is -1, my b is 0. So, start at 0, go, go down 1 over 1, parallel line. My perpendicular line, y equals x, in this case m is 1, b is 0, so we start at 0, 0 again. In this case we go up 1 over 1, perpendicular. Okay? Alright, next example. The following table gives the values for the linear function f of x equals mx plus b. Determine b. Alright. Hopefully you guys can tell that this is pretty much slope-intercept form. These points make up a line. Okay? So, if you were to find the slope, first of all, the slope between any of these 2 points, because it makes a straight line, well, you already know it makes a straight line because it's linear, just pick 2 points and find the increments. So this is going to be, let's just go from here to here. So we've got -4 over 3 minus 14 over 3 over 1 minus -1. The minus negative becomes a positive. Here I have a common denominator, so I'm just going to work with the tops. -4 minus 14 is -18, so I've got -18 over 3 all over 2. Okay, so this is the same thing as -18 over 3 times 1/2, because when you divide fractions, you flip the second fraction and multiply. So I've got -18 over 6, which gives me -3. So there's our slope. Now, we know that y equals mx plus b, or f of x equals mx plus b, either way. Let's just use this point. Here's my x, here's my y. Plug them in. 14 over 3 equals -3 times -1 plus b. I apologize I didn't give you guys enough room. Don't know what I was thinking. 14 over 3 equals 3 plus b. I'm going to subtract 3 from both sides. And let's see here. I'll just do a little something over here. 14 over 3 minus 3. 3 is like 3 over 1. I'm going to need to find a common denominator. So I've got 14 over 3 minus 9 over 3. Just work with the tops. And you get 5 over 3. So b, this goes away, b is 5 over 3. And that's what we're looking for. Alright, you guys go ahead and try this one. Pretty much it's the same thing, they just made the table vertical instead of horizontal. Alright, this is the answer you guys should have gotten. Alright, last example. Let's do this. Find the relationship between Fahrenheit and Celsius temperature. Then find the Celsius equivalent of 90 degrees Fahrenheit and the, let's see here, freezing point is going to be 0 degrees for Celsius and 32 degrees for Fahrenheit. Boiling point is going to be 100 degrees for Celsius and 212 degrees for Fahrenheit. It's also important to know that the relationship between these is linear. That means it's going to make a straight line. So we can use y equals mx plus b. The only difference is we're going to use f and c instead of x and y. Okay? So we have our points. If we use this one here, we're going to get 32 equals m times 0 plus b. If we use this one here, we end up with, see, I'll write it over here. 212 equals m times 100 plus b. This equation is kind of nice because the 0 cancels out the m and we have our b right away. Okay? So b is 32. M, if we plug this in, we can solve for m very easily. So I've got 212 equals 100m plus 32. I'm going to subtract 32 from both sides. This gives me 180 equals 100m divided by 100. Zeros cancel out. 18 over 10 becomes 9 over 5. So our equation is F equals 9 over, I forgot the equal sign, sorry, 9 over 5 C plus 32. So, to solve for these, we just have to plug it in. Let me change colors. If I plug in 90 for F, I could just find out what I get for C. You know what? I'm pretty confident you guys can do that. I'll just tell you what it is. For C, you're going to get approximately 32.2 degrees. That's the first part, the Celsius equivalent. And Fahrenheit, if you were to plug in -5 for C, you're going to end up with 23 degrees. I think I'm confident at this point that you guys are able to plug numbers into an equation and solve. Alright, you guys, go ahead and try this one. And then when you think you got it, hit play. Alright, I'm going to actually do this one out for you guys because it's a little bit different. When the pressure P experienced by a diver underwater is related to the diver's depth by this equation here. K is a constant. That means K is a regular number. It's not a variable. It's not something that's going to change. We need to find what K is. When D equals 0 meters, the pressure is 1 atmosphere. Okay, so let's write this down. We've got P equals KD plus 1. First step, we've got to figure out what K is because K is a constant. Now we know when D equals 0, P equals 1. So P equals 1, K, D equals 0. That works out. Let's try the next one. The pressure at 100 meters is this many atmospheres. So this obviously would just give you 1 equals 1, which doesn't really tell us anything. But if you plug in the other one, we should get something. Okay, so I'm going to subtract 1 from both sides. I've got 99 equals 10.94K. And I don't think we really need a graphing calculator for this one. I'm just going to pull up my regular computer calculator. K equals 9.05. Okay, so here is my new equation. P equals 9.05 D plus 1. Okay, now we just need to find the pressure at 50 meters. So I'm going to plug this in for D. So 9.05 times, and these are atmospheres. I actually don't know the abbreviation. I'm just going to leave it like that. ATM. Alright, and that's all.